Okay, here's the recording in progress. So share the screen. All right, so we're doing parabolas this week. I introduced the concept of the parabola yesterday. We'll do more today. And tomorrow's quiz will be on the parabola. A reminder, we have a short week this week because of Thanksgiving. So your quiz, normally it's on Friday, but it's tomorrow already. And then we have a nice Thanksgiving holiday, Thursday and Friday. Okay. So we're doing the parabola. After that, next week, we have the ellipse and the hyperbola. You don't have to write that down now. We'll worry about it when we get to it. And then we have something called parametric equations, and then that'll be it for the course. Okay, and reminder, I am now planning on having the last regular exam on Thursday the 9th, not on Friday, unless something goes wrong. Okay, so we'll have the last regular exam on the parabola, ellipse, hyperbola, and parametric equations on Thursday the 9th. It doesn't mean I'll have your test ready by the next day necessarily. I'll try, but I'm not going to guarantee it. But I will give you the solutions video. So you're going to study off the solutions video for the final exam. Okay, I don't even know if I'm going to give you the exam 6 by Monday the 13th, but I'll try. But you know, I'm giving lots of other tests. So, but again, you know, you'll get it eventually. Don't worry about that. So to study for the final exam, you'll study off the videos anyway. Okay, and you have 8:10 to 10:40. Please notice the different starting time. We'll start at 8:10 on that day to 10:40. That is our last meeting. Okay, I am supposed to tell you about office hours the rest of the week. It does seem kind of weird to tell you about office hours after the final exam, but in case you want to catch me for some reason, you can always email me. But I do have office hours during finals week, Tuesday, Wednesday, Thursday, 8:10 to 10 a.m. That's the 14th, 15th, and 16th. It'll be a different Zoom session. So if you really, really want it, catch me during office hours, email me ahead of time. I'll have to give you a separate Zoom link for that. But yeah, I'm guessing most of you don't need to come to office hours because there's nothing to discuss except, you know, the final exam. And I'll either tell you the final's ready or it's not ready. And I would email you the result just as I normally do anyway. So, yeah, so that's that. Okay, so we'll do more parabolas today, probably finish early. Tomorrow you get a quiz on parabolas. The most likely scenarios I'll give you a parabola opening left, right, up, and down, so you can get used to all of them. Okay. Okay, so that's that. So here we go. Quick reminder of where we were. Okay, so a parabola is determined by a focus and a directrix. Okay, here's a formal definition. You're not responsible for that, but in case you want to know, okay, you want all the points that are the same distance away from the point and the line. Okay, so here's a parabola opening up. Put these on your cheat sheet. Vertex, I'll call it V. It's always at the origin unless the problem is translated like this. Focus is always on the inside of the curve. So here it's 0p. P is the focal distance. Directrix y equals negative p. That's x squared equals 4py. Turn this 180 degrees and it opens down. So it looks like this. That's x squared equals negative 4py. Focus is 0, negative p. Directrix y equals p. Turn this 90 degrees so that it opens to the right. Looks like this. Y squared equals 4px. Focus is at p0. Directrix x equals negative p. Turn this graph 90 degrees so it opens to the left. Y squared equals negative 4px. Focus is negative p0. Directrix x equals p. Okay, you must use these formulas, not the ones that are given in the text. Okay, to make it easier on me when I grade you. Okay, again, mathematically, there's nothing wrong with what the text has, but most books do this. I think it's easier to have it this way. And these vertices are always at the origin, 0, 0. And unless you see a translation like this, the vertex is always at 0, 0. Yes, question.
That first picture, would you go back to it with the even lengths up a little bit right there? So that's the directrix at the bottom or the x-axis?
This is the directrix in general. It doesn't have to be the x-axis, although it could be. But
okay,
it's not meant to be the x-axis. It's just somewhere. So that's why I didn't put an XY coordinate system.
thank you.
Welcome. And this one opens this way. Obviously, if I turn it, you know, upside down, then it's opening down. And, you know, I turn it like that, then you have to picture what's opening to the right. And I turn it like that, you know, it's open to the left. You know, if you just turn the picture, that doesn't do anything. I guess, I could even look from this angle. I could just physically put my body here, and then it looks like it's opening down. I could physically, turn the paper like that, and then it looks like it's opening to the right, and I can physically turn it like that, it's opening to the left. I mean, all the math stays the same. The directrix is still going to be outside here, and the focus is always on the inside of the curve. Okay. All right, so I did a few last time, and we'll do more. All right, so now, number 9. So last time I think I did 1, 3, 5, and 7, one of each type, open, left, right, up, and down. Okay, number 9, x squared minus 6x plus 9 equals 2y. I realize this is factorable. X minus 3 squared equals 2y. All right, so this is a translation. There's an x minus 3, but there's no y plus or minus blah, blah, blah. So the vertex is now 3, 0. And then I think to myself, okay, square root in x, not in y, positive. Square root in x, not in y, positive. That's going to open up. Right? That's of this nature. So you ask yourself, okay, is there a positive or a negative? And is it squared in x but not in y? It's going to go up or down. If it's squared in y but not in x, it's going to be left or right. And so this one, let's see, we said squared in x, not in y, and positive. So it opens up. Okay, now I have to force this to look like x minus 3 squared equals 4py. Okay, 4py. So 4p is equal to 2. So I solve 4p equals 2. That means p is a half. So my focal distance is 1/2. So starting from the vertex, which in this case is offset to 3, 0. I know it's opening up. So I go half a unit up, half a unit down. So half up, 3 comma half. Half down, don't put the point. Remember, the directrix is an entire line. So it'd be incorrect if you put 3 comma negative half. You have to draw an entire horizontal line. The directrix is y equals negative a half. Right? Okay, then number 11, you have to complete the square, which is a recurring theme. X squared minus 4x minus 2y plus 2 equals 0. So let me show you how to do that one. Okay, first throw these two on the other side. So x squared minus 4x equals 2y minus 2. All right, so remember, for completing the square, right, you take half the coefficient of x or y, as the case may be, and then square it. So half of negative 4 is negative 2. Square it. Negative 2 squared becomes 4. Right? Add that 4 to both sides. So I have it here in red. If you can kind of see that red part there. That's what I got. And so now this factors into x minus 2 quantity squared. So you want to write it as blah, blah, blah squared. Okay, this becomes 2y plus 2. Factor out the 2. So you have 2 parentheses y plus 1. So now this looks like the translated conic section that I'm talking about. Okay. I stuck in an expression, conic section. That's parabola, ellipse, hyperbola, conic, C-O-N-I-C. You don't have to really memorize that. But what we're studying are the so-called conic sections, C-O-N-I-C, conic sections. That's the parabola, the ellipse, and the hyperbola. I'm not writing it down because I'm not emphasizing it, and you won't be tested on it anyway. So, right. So yes, you can have the usual student strategy of, hey, he's not going to test me on it, so why should I learn it, right? And that's sort of my emphasis on it too. They're called conic sections. I'm not testing you on it, so you can take it or leave it. I'm guessing most of you are going to leave it. All right, so now where's my vertex? X minus 2, y plus 1. So the vertex is 2, negative 1. Okay, and let's see, squared in x, not in y, and positive. So once again, it's going to open up. So not much different than the previous one. Okay, so my base form is x squared equals 4py, except for the translation. So again, the 2 represents 4p. If 4p is 2, once again, p is a half. 4 times p, 4 times a half is 2. So the vertex is 2, -1, and the p is a half. So it's basically the exact same picture as this, same p-value, except my vertex is 2, -1. So I go to 2, -1, half a unit up, focus is 2, -1/2. Go half a unit down, draw this horizontal line, which is y equals -1.5 or -3/2. And there we go. Okay, so let's practice some more of this completing a square. So 13. Okay, in case you're wondering, yes, it does look like I'm practically doing all the problems, and I know none of you are going to stop me on that. All right, so in case you're snickering behind the scenes, say, it looks like he's doing all the problems. Yeah, I might be, and I know it. Okay, but I have to show you enough problems how to do it, but to show you enough problems to do one that goes left, right, up and down, I almost end up have to do all the problems. So yes, I'm aware if I end up doing all the problems, fine, so be it. All right, y squared minus 8y plus 12 equals 2x. So I move the 12 over. Okay, and then again, I complete the square on the y squared minus 8y. So take half the coefficient of y, square it. So half of -8, -4. Square it, 16. In red here, add that 16 to both sides. So the right side is now 2x plus 4. This factors in a y minus 4 squared. Factor out the 2 here, 2 parentheses x plus 2. All right, so we can read the translation. First, I see squared in y, not an x, positive. So what's that? Squared in y, not an x, positive, opens to the right. So I've got a tiny little parabola open to the right there. Its basic form is this one. Squared in y, not an x. That means it's opening to the right and positive coefficient. So let's see, where was I? Okay, and there's a 2 again. So the text doesn't seem to deviate that much from it. 2 represents 4p. 4p is 2. That means, once again, p is a half. 4 times p times x plus 2. So y minus 4 squared equals 4p x plus 2. All right, so where's my vertex? -2, 4. Be careful, it's not 4, -2. It's always x comma y. So -2, 4. So here's -2, 4. I know it's opening to the right. So I go half a unit to the right for the focus. There it is, -1.5 comma 4. I go half a unit to the left for the directrix. X equals -2.5. So it's a vertical line. And then there it is, opening to the right. Okay, so 15. 2x squared plus 4x minus 9y plus 20 equals 0. That one. Okay, throw these two over. Now, this time, there's a coefficient above the x squared. You might recall anytime you do completing the square, you don't want that 2 there. So I just divide out the 2. Yes, that's going to give me a fraction, but so be it. Got to live with it. So divide by 2, x squared plus 2x equals 9 over 2y minus 10. Complete the square. Half of 2 is 1. 1 squared is 1. So add 1, add 1. This becomes x plus 1 squared. This is 9 over 2y minus 9. Well, if I factor out 9 halves, 9 over 2, I get y minus 2. So it's like if I take out the 9 over 2, there's a 9. I had to divide by 2, so to compensate, I multiply by 2. So it's y minus 2. And if you're not sure about that, distribute this back out, right? What's that times that? 9 halves y. What's that times that? Negative 9. So there we go. All right, so where's my vertex? Read it off. Negative 1, 2. So my vertex v, negative 1, 2. Once again, squared in x, not in y, and everything's positive. So it's going to open up once again. Unfortunately, the author gave too many examples where we're opening up, but you should be able to adjust accordingly. Again, quiz tomorrow, the most likely scenarios, I'll give you one of each. One that goes up, down, left, and right. So you'll follow, this scheme. If it looks like this, up. If it looks like this, there's a negative, down. If you got y squared equals 4px, right. Y squared equals negative 4px, left. Remember, you might have to manipulate the equation, right? Might have to move stuff around until you can recognize, until you can say, oh yeah, this opens left, right, up or down. Sometimes you can't tell right at the start until you manipulate a little bit. Okay. So let's see, where were we? I was doing this thing. Right, and this represents 4p. 4p is 9 over 2. That's very clumsy. So 4p equals 9 over 2. Multiply both sides by 1/4. And so p is a very awkward 9 over 8, or 1 1/8. Okay, so how do I do that? Set down the vertex at negative 1, 2. It's opening up. And then I go up 1 1/8. So 1 1/8 plus 2 is 3 1/8. So here's my focus. I just drew it a little bit higher than 3. So negative 1 comma 3 1/8. And then I go down 1 1/8. 2 minus 1 1/8 is 7/8. So here's my directrix. I just went a little bit lower than y equals 1. So y equals 7/8 is my directrix.
Would you does it matter if we leave 3 1/8 as 25 over 8 on the test, or
25 over 8 is fine. Full credit.
okay, thanks.
Yeah, it's just a lot easier to plot. So you say 25 over 8, no, where is that, right? So I actually have to divide it anyway. So, do I put the dot there or there? It's, 3 1/8. So that tells me it's a little bit higher than 3. So there it's preferable to say 3 1/8 as opposed to 25 over 8. So where's 25 over 8, right? You got to figure out where to put the dot anyway, so. Okay. All right, so 21. Yes, what do you know? I'm actually not doing all the problems. Okay, let's see. Opening to the right, vertex of the origin, directrix x equals negative 1. That means the p is equal to 1. So opening to the right, y squared equals 4px. P is 1. So it's just y squared equals 4x. That's all there is to it. Okay. All right. So that is that. Let's see, what else did I want to show you? Let me show you these problems. 31. A. Find the equation of a parabola with axis parallel to the y-axis. Vertex that passes through the point. So vertex of the origin passes through 4, 6. They said the axis was parallel to the y-axis, so I know it's going to be x squared, not y squared. Okay, so here's 0, 0. I know automatically it's x squared equals 4py. How do I find the p? Well, they told me it goes through 4, 6. Just put a 4 here and a 6 here, solve for p. So 4 squared is 16. 4 times 6 is 24. Divide by 24, p is 2/3. Put the 2/3 back here, and that gives me 8/3. So x squared equals 8/3y. Get this thing focused here. Yeah. So there we go. Okay, part C. Vertex is 1, 2, passes through the point 5, 8. So 1, 2, 5, 8. So x gets changed to x minus 1 squared. I know it opens up because 1, 2 is here, 5, 8 is here. If they had 5, negative 8, that'd be down here. I know it opens down. So it's got to go up. Equals 4p parentheses y minus 2. Like so. Okay. And now to find a p, again, I just plug in x is 5, y is 8, and then I just do that algebra right there, right? Okay, so put 5 there, 8 there. So 4 squared is 16. That's going to be 4 times 6. 16 equals 24p. So p is once again 2/3. So put 2/3 right here, and you have your answer. X minus 1 squared equals 8/3 times y minus 2. Okay. All right. I'll show you a couple of these. I'll start from scratch on these so you don't see ahead of time what it is. Determine the equation of the parabola that satisfies the given conditions. Okay, so let's try some of these. I'll show for you 25. So 25, I'll write it for you here. Okay, 25, it says the vertex is -2, 2. Directrix, y equals -2. No, I'm looking at it wrong. That's 23, sorry. 23, focus. No, I'm reading it totally wrong. Focus -2, 2. I'll get it. Focus -2, 2, directrix, y equals -2. Okay, I think I got it now. Let's take a look at what we got. 1, 2, 1, 2. Okay, focus is at -2, 2. Directrix is y equals -2. So where's my vertex? Oh, it's halfway between these. Right there. Which way does this have to open? Up. Focus is always on the inside. Something like that. So that's x squared equals 4py if the vertex was at the origin. I now know the p is 2. That's a distance either here to here or here to here. So p is 2. Vertex is at -2, 0. So it's a translation from the origin of 2 to the left. So that's x plus 2 squared equals 4 times p, which I now know to be 2. Y minus nothing, so I can just leave it like that. So my final answer is x plus 2 squared equals 8y. And there we go. Okay, 25 is what I was aiming for, but I totally botched it. So what do I give that now? Vertex is -2, 2. Directrix is x equals 2. Vertex -2, 2. Directrix x equals 2. Okay, so it looks like they're using a lot of the same points here. 1, 2, 1, 2, 1, 2, 1, 2. Okay, x equals 2 is a vertical line. Vertex is -2, 2. 1, 2, 1, 2. Vertex. Which way is this going to open? Vertex is here. The focus is always on this side. So it's going to be on the inside, like so. Okay. How far is it from here to here? 4. So P is 4. So I go 1, 2, 3, 4 this way. And there's my focus. So my focus is -6, 2. I was going to go this way. My focus is always on the inside. Directions on the other side. Open to the left. Opens to the left. Oops. Well, that is the form y squared equals -4px if I'm at the vertex of the origin. But this is translated. So 2 to the left, 2 up. So y is now y minus 2 squared equals -4p. My p is 4. And x becomes x plus 2. Okay, so just make it y minus 2 squared. Running out of ink here. Y minus 2 squared equals -16 times x plus 2. Okay. And that's the way it goes. All right, folks, so that was all I was going to do for today. I'm almost done with this section. I can do a couple more tomorrow. Okay, so I'll give you the quiz, do a couple more tomorrow, and that would just about be it. Okay, let me check the chat. Do 33 and 35. That was actually going to be on my schedule for tomorrow. So if you can hang on until tomorrow, that was what I was going to do for tomorrow. For those. Okay, if that's all right with you. Okay, so let me stop the share and see if there's any other thing in the chat. Otherwise, I'm done. Okay, any other questions, please? So tomorrow you get a quiz. You'll have all 4 parabolas, one that goes up, down, left, and right. Okay, and just go from there, as it were. Okay, anything else, folks? Otherwise, we're done. All right, that's it for today, folks. So have a good day, and we'll see you tomorrow. Okay, all right, bye, everybody. Thank you.
Bye.